Crash Course Instrumentation, Episode 45. Ranges, Scales, and Why You Shouldn't Peg Your Meter. Nothing says oops like pegging a meter or blowing a fuse. In this episode of Crash Course Instrumentation, we're covering ranges and scales on multimeters, and how choosing the wrong one can lead to bad data, equipment damage, or even personal risk. Whether you're using a digital or analog meter, this episode will help you stay safe, stay accurate, and avoid common mistakes. What is a range? A range is the maximum value your meter is set to read. If you're measuring voltage and your meter is set to a 20-volt range, anything above that might display as OL, meaning over limit, or peg the needle if you're using an analog meter. Auto-ranging meters select the appropriate range automatically, but manual range meters require you to choose the right range based on what you expect to measure. Picking the wrong range can result in readings that are too coarse, confusion about what you're actually seeing, possible overload of your meter. What is a scale? The scale is how the measurement is visually presented, whether on an LCD display or on a dial. On analog meters, multiple scales are printed on the face. You need to match the scale to the range you selected. Misreading the scale is one of the most common analog meter mistakes. Pro tip: if your analog meter has a mirror behind the needle, use it to line up your eye and reduce parallax error. Why pegging the meter is a problem. If you're using an analog meter and the needle slams to the right edge, that's called pegging the meter. This can damage the internal movement, blow the fuse, give no useful reading. Even with a digital meter, measuring something outside the set range can display OL, flash a warning, or trigger internal protection. But don't count on your meter to always protect itself. Some cheap meters may not have good protection circuits at all. How to choose the correct range. If you're using a manual range meter, start with the highest range, then work your way down. This protects your meter and helps prevent false readings. Once you're in the ballpark, lower the range to get a more precise reading. Most meters are most accurate in the middle 50% of the range. For example, set to 200 volts to check a 120-volt circuit. It's set to 20 ohms for measuring a 10-ohm resistor. Remember that using too low a range can cause OL or pegging. Too high a range might give you low resolution and make it hard to interpret what's going on. Auto-ranging versus manual ranging. Auto-ranging meters are faster for general use and help reduce mistakes. But they can also be slower to settle when the signal fluctuates, mask unexpected values or spikes. Manual range meters give you more control, especially when testing unstable circuits or when recording data for logs. For industrial techs, manual mode is often preferred for consistency and accuracy. Understanding CAT ratings and why they matter. All multimeters are rated by their CAT safety rating, CAT Y through CAT 4, and this determines how safely they can be used in different environments. Watch CAT TI. Low-energy electronics like battery-powered devices. CAT 2, single-phase outlets and small appliances. CAT 3, distribution panels, lighting systems, and branch circuits. CAT 4, utility service entrances and outdoor connections. Always use a meter that matches or exceeds the environment you're working in. If you're measuring a 480-volt panel, a CAT 2 meter is not safe. You want CAT 3 or IV with the right voltage rating. Also, be sure your meter has proper fused inputs and meets the latest UL standard for overvoltage protection. Does meter price affect accuracy? In general, yes. More expensive meters usually have better accuracy, faster response time, and higher safety ratings. Inexpensive meters may have lower resolution, slower display refresh, less robust protection circuitry. Higher-end meters from trusted brands provide better shielding, more accurate readings at low voltages or currents. Data logging and stability features. If your work involves troubleshooting sensitive circuits, high-voltage systems, or field diagnostics, investing in a better meter pays off. Did you know? Early analog meters were so sensitive that pegging the needle could literally bend the movement spring or demagnetize the internal coil. That's why experienced techs always started with the highest range available, a habit that still pays off today, even with digital meters. Quick recap. A range sets your meter's upper limit. A scale is how you interpret the value. Pegging the meter can damage it or mislead you. Start high, then dial in for precision. Manual mode gives you control. Auto mode gives you convenience. Check your meter's CAT rating before testing higher energy circuits. Accuracy and protection improve with higher quality meters. Thanks for watching episode 45 of Crash Course Instrumentation. Next time, we'll tackle how to troubleshoot sensors and signal loops using everything we've learned. Special thanks to Tony Kuphaldt and the open source ModEL project. Explore more at ibiblio.org/kuphaldi/Socratic SOA model. Like, subscribe, and join our Facebook group for more practical tools, history, and hands-on tips.